So far, we know how to find the determinants of 1 by 1, 2 by 2, and 3 by 3 matrices. We now develop a different method for evaluating the determinant of a square matrix of size n by reducing the problem to evaluating the determinant of a square matrix of size n minus 1. Then repeating this process until we get to a 2 by 2 or even just until 3 by 3 matrices. But first, we define what a cofactor is. Given a matrix, a square matrix A of size n, we define the capital M sub ij as the submatrix of A, which is of size n minus 1 by n minus 1, obtained by deleting the ith row and jth column of A. And when we have this capital M sub ij, we now define the ij cofactor of A. It is equal to -1 raised to the sum of I and j times the determinant of our submatrix Mij. This is written by or notated as A sub ij, capital A sub ij. Given these new definitions, we have this result. The determinant of A is equal to these summations. For our first summation, this is called the cofactor expansion along row I. So as you can see here, all the row numbers are I, and the columns runs from 1 until n, which is the size of the matrix. While for the second summation, this is called the cofactor expansion along column J. So if you will observe, all the column numbers are J, and the row numbers runs from 1 to until size n. Until n, which is the size of the matrix A. Let's try them out in our example. Suppose we want to evaluate the determinant of this matrix A, which is of size 4. We have a tip here. Use cofactor expansion along row or column with many zeros. So in our matrix, it is best to expand either along column 2 or row 3, because this column 2 and in row 3, we have 2 zeros. Let's do along row 3. The cofactor expansion along row 3, so we have this sum, and all the row numbers are 3. And then for each term, the columns runs from 1, 2, 3, and 4, since the matrix is of size 4. And then we substitute the values for the small a's. Now, this is the 3 here along row 3. And then we substitute. We have 3 for A31. For A32, it is 0. A33 is 0. And A34 is -3. The middle terms, 0A32 and 0A33, these are just zeros. So we are left with 3A31 minus 3A34. And now we compute for A31 and A34 separately. Let us solve first for A31, the 3-1 cofactor of A. The 3-1 cofactor is equal to -1 raised to the sum of 3 and 1. So we have 3 plus 1 here, times the determinant of M31. That is the submatrix of A obtained by deleting the third row and the first column. So we have 2, -3, 4, 2, 1, 3, and 0, -2, 3. Now we simplify. We have here -1 raised to 4. And then for the second factor, let's get the determinant. This is a 3 by 3 matrix. So first what we do is get the product of all the entries in our main diagonal. So that is 2, 1, and 3. So we have 6 plus the next, we have negative 3 times 3 times 0, that is 0. Next is 4 times 2 times negative 2, that is negative 16, minus 0, 1, 4, that is 0. Negative 2 times 3 times 2, that is negative 12. And then 3 times 2 times negative 3, we have negative 18. Negative 1 raised to 4, that is just positive 1. While for 6 plus 0 minus 16, we have negative 10. And for negative 12 minus 18, that is negative 30. So we have minus negative 30, so we have here positive 30. And then simplify, we have 20. For our next cofactor, let us solve for A34. So that is negative 1 raised to the sum of 3 and 4 times the determinant of the submatrix M34. The submatrix M34 is obtained by deleting the third row and fourth column of A. So we have this one. I leave it to you as an exercise to check this determinant. So we have negative 1 raised to 7 times computed determinant. Negative 1 raised to 7, that is negative 1. And if we simplify the determinant here, negative 4 plus 4, that is just 0. Negative 12 plus 16, that is positive 4. Then we have minus here outside, so we have negative 4. But we have negative 1 raised to 7 here, which is negative. So the 3, 4 cofactor of A is positive 4. Now we substitute these values 20 and 4 to our formula in our determinant, in our cofactor expansion along row 3. Previously, we have this solution, and then let us substitute the values we just obtained. We have 20 and 4, and then simplify. We get 48. So the determinant of this 4 by 4 matrix is 48. As an exercise, solve the determinant of this 4 by 4 matrix.